before starting the videotape, you should have before you a list of the problems that we're going to be discussing. If not, shut off the machine, go up to the person who is running the lab, and ask for a copy of the sheet. Okay? Now, the first problem on the sheet I have written up here on the board. The sum of the squares of two consecutive positive odd integers is 130. Find the integers. Okay, we will start by letting x represent the first of these integers. The question is, how can we represent the second one? Okay, now if we're talking about just consecutive integers, for example, 3, 4, 5, we can represent them, say, x plus 1, x plus 2. But if we're talking about odd integers, for example, 3, 5, 7, if x represents the first, it would be wrong to represent the second as x plus 1. We would represent the second as x plus 2, the third as x plus 4. They should be going up by 2. Okay? Some people are confused and they feel that they should have like x plus 1 and x plus 3 because they're odd. That doesn't matter here. Here, x is 3. We're starting off with an odd number, say. If you add 2 to an odd number, even though 2 is even, if you add 2 to an odd number, you will get another odd number. Similarly, if you add 2 again, you will get another odd number. All right. So if x is the first of the odd integers, then x plus 2 would be the second. And these are positive odd integers. Now, it says the sum of the squares of two consecutive positive odd integers is 130. The sum of the squares. Okay, that means square the first and add to it the square of the second, and that should be 130. The sum of the squares of two consecutive positive odd integers is 130. Notice that I did not say the square of the sum. If it had said the square of the sum, you would first add them together and then square the sum. Okay, so if a problem referred to the square of the sum, we do it this way. But here it said the sum of the squares. Okay, now let's work this out. X squared plus, now x plus 2 squared is x plus 2 times x plus 2. Using the FOIL method to expand this, first times the first, x squared. Outer gives you plus 2x, and inner gives you plus 2x, that's plus 4x. Last gives you plus 4. First outer, inner last, equals 130. Or 2x squared plus 4x plus 4 equals 130. We can subtract 130 from both sides of the equation, giving us 2x squared plus 4x minus 126 equals 0. We can now divide both sides of the equation by 2, or factor out a 2. 2 times x squared plus 2x minus 63 equals 0. Checking this, 2x squared plus 4x minus 126 equals 0. Okay, so dividing both sides by 2, we just have to worry about x squared plus 2x minus 63 equals 0. I'm going to write that up over here again. X squared plus 2x minus 63 equals 0. Okay, now we're going to try to factor this second-degree equation, this quadratic equation. Okay, it's the simplest kind of factoring, where we are looking for two numbers which multiply to minus 63 and add to plus 2. All right, so we're going to be using plus 9 and minus 7. If you're weak on factoring, of course, we have videotapes that you can look at, which will help you review your factoring. Okay, but here, checking by FOIL, x squared plus 9x minus 7x, that's plus 2x minus 63. So we have x plus 9 equals 0, x minus 7 equals 0, x equals minus 9, x equals 7. Two possible answers. Now, it said over here we're looking for two consecutive positive odd integers. Positive. So we will reject x equals minus 9 since it's not positive. So our only answer here is x equals 7. X equals 7 would be the first integer, x and x plus 2. Okay, these are the consecutive positive odd integers. If x equals 7, then x plus 2 would be 9. And I claim that the answers are 7 and 9, two consecutive positive odd integers. The question is, have we found the answer? Is this correct? And let's check it. In the words of the problem, don't go back to the equation, which conceivably could be incorrect. Go back to the actual words of the problem. The sum of the squares of two consecutive positive odd integers is 130. The sum of the squares. Well, the first one is 7. When you square it, you would get 49. The second one is 9. Squared, you get 81. And when you add them up, you do get 130. Okay, so we have found two consecutive positive odd integers, the sum of whose squares is 130. So we've completed the first problem. Okay, now let's look at the second problem on our sheets. A rectangular garden is surrounded by a path of uniform width. If the garden is 5 yards by 8 yards and the area of the path is 30 square yards, find the width of the path. Okay, think about that problem for a few moments. See if you can make a sketch which represents the garden. In a problem like this, involving geometry, okay, it's always a good idea to try to draw a picture so that you can actually visualize what's going on. All right. We're talking about a rectangular garden, and it's surrounded by a path of uniform width. Okay, let's say we have a garden which is 5 yards by 8 yards, rectangular garden. We have surrounding it a path of uniform width, something like this. Okay, and we're trying to find the width of the path. Let us denote the width of the path by x. In other words, x represents that quantity, and since the path has uniform width, this as well, this, and this. Let x equal the width of the path. And of course, we have to make sure our units are okay. It's really the number of yards in the width of the path. It's in yards. Okay, now we have information about the garden. We know the area of the path, and we're trying to find the width of the path. So we're going to try to write down some sort of an equation which expresses what we know here. What we can do is the following. We can say that the area of the garden and the path together is equal to the area of the garden plus the area of the path. The whole is equal to the sum of its parts here. We have, if we take the garden and the path together, the entire large rectangle, that would be equal to the area of the garden, which is this inner rectangle, plus the area of the path which surrounds it. All right. Now, we are told the area of the path is 30 square yards. The area of the path is 30 square yards. We are told the dimensions of the garden, and since it is a rectangular plot here, since it's 5 yards by 8 yards, the area of the garden must be 40 square yards. Okay, so the area of the garden, okay, this is 40 square yards. Okay, inside here. The area of the path which surrounds the garden is 30 square yards. Okay, we say that is equal to the area of the garden and the path together. Now, let's see if we can express that. We have here a large rectangle. We are looking for the dimensions of this large rectangle. The inner rectangle is 5 by 8. The outer rectangle would have dimensions. Well, let's look here. If this is from here to here is 8, and we're adding x on here and x on here, this dimension for the outer rectangle must be 8 plus 2x. 8 yards gets us from here to here, and we add x on either side. So the length of the entire, the garden and the path together, the entire length here is 8 plus 2x. Similarly, the width, which was 5 from here to here, we're adding x on either end. So the width of the entire plot here is 5 plus 2x. So the area of the garden and the path together, we have a large rectangle here, and it's going to be length times width. It's going to be 8 plus 2x times 5 plus 2x. And we have written down an equation which expresses the words of the problem here. We have the area of the garden and the path together is equal to the area of the garden plus the area of the path. From here on in, it's going to be straight algebra. Let us use FOIL to expand the binomials we have here on the left. First, we have 8 times 5, that's 40. Outer is plus 16x. Inner is plus 10x for plus 26x. Last, 2x times 2x, that's 4x squared, equals 40 plus 30, or 70. All right, subtracting 70 from both sides of the equation, we get 4x squared plus 26x minus 30 equals 0. And I'm going to divide both sides of this equation by 2, or factor out of 2. And I'm going to rearrange the terms. I feel more comfortable with the variable term, the quadratic term, coming first. So let's make it 2 times 2x squared plus 13x minus 15 equals 0. Checking this, we have 4x squared plus 26x minus 30. Okay, don't forget we're taking 2 out of each term. Now we want to solve this quadratic equation, and we can solve this by factoring. And we can divide both sides by 2, so we're just talking about 2x squared plus 13x minus 15 equals 0. And this factors very simply into, let's see, we know that the first terms have to be 2x and x. And with a little trial and error, we can hit upon plus 15 and minus 1. Checking by FOIL, 2x squared minus 2x plus 15x, that's plus 13x, minus 15. All right, so we have x minus 1 equals 0, and 2x plus 15 equals 0. This one gives us x equals minus 15 halves, which we would naturally reject, since x represents the width of the path, and a negative width does not make any sense. Here we get x equals 1. If x is equal to 1, x is the width of the path in yards, our answer would be, find the width of the path. The width is the width of the path, 1 yard. And now we have to check to make sure we have found the correct solution. Let's see what we have. We know that the area of the path is 30 square yards, and the area of the actual garden itself is 40 square yards. So the area of the large rectangle should be 70 square yards. Okay. Dimensions would be, for the large rectangle, would be 8 plus 2 times 5 plus 2. In other words, we have the 8, and we're adding a yard on either end. So for 10, 5, we add a yard on either end to get 7. 10 times 7 is 70, which is equal to the 30 plus 40. Okay. The 70 square yards that we find for the area of the large rectangle is equal to the area of the actual garden plus the area of the path. It does check out. All right, the third problem on our sheet reads the following. The lengths of the three sides of a right triangle are given by three consecutive positive even integers. Find the lengths of the sides. Okay. It's a right triangle. We can let x represent one leg of the triangle. Then the other leg, since these are positive, consecutive positive even integers, could be designated by x plus 2. And of course, the greatest of the three integers would represent the hypotenuse. The hypotenuse is the longest side of the right triangle. So if this is x plus 2, this would be x plus 4. All right, it doesn't matter, okay? In an earlier problem, we were representing consecutive odd integers by x and x plus 2, and here we're representing consecutive even integers by x and x plus 2. Okay, this works because if x is odd, for example, if x were 3, 3 plus 2 would also be odd. On the other hand, if x is even, for example, 4, 4 plus 2 would also be even. Okay, so it will work out for us. Okay, let x equal the length of the shortest side. X plus 2 is the length of the other leg, and x plus 4 is the length of the longest leg, the length of the hypotenuse. What we're going to use here, of course, is the Pythagorean theorem. We know that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two legs. Okay, so let's write that down. X squared plus x plus 2 squared is equal to x plus 4 squared. The square of the longest side, the square of the hypotenuse is equal to the sum of the squares of the other two legs. All right, this gives us x squared plus 4x plus 4, expanding x plus 2 times x plus 2, equals x squared plus 8x plus 16. All right, we can subtract x squared from both sides of the equation. Okay, these will drop out. We'll be left on the left with x squared plus 4x plus 4, and on the right, 8x plus 16. Let us now subtract 8x from both sides of the equation, giving us x squared minus 4x plus 4 equals 16. And finally, we're going to subtract 16 from both sides of the equation to put our quadratic equation into standard form. X squared minus 4x minus 12 equals 0. Okay, it is now in an ideal form to solve by factoring. We are looking for two numbers which multiply to minus 12 and add to minus 4. So we're going to be using minus 6 and plus 2. X squared plus 2x minus 6x, that gives us a minus 4x minus 12. We get x minus 6 equals 0, x plus 2 equals 0, x equals 6, and x equals minus 2. Since x represents the length of a side, we will reject the negative value, giving us our answers are x, x plus 2, and x plus 4, the lengths of the sides of the triangle. You had, remember, x, x plus 2, and x plus 4. So we have 6 here, 6 plus 2, that's 8 here. 6 plus 4, that's 10 here. So the lengths of the sides of the triangles, 6, 8, and 10. And check. We have found 3 consecutive positive even integers, 6, 8, and 10, that are sides of a right triangle. Well, to show that, we simply show that the Pythagorean theorem does hold here. That 6 squared plus 8 squared does equal 10 squared. We have 36 plus 64. It does equal 100. It does check out. Okay, I am writing the 4th problem on the board. A boat travels 8 miles per hour in still water. The boat travels upstream 30 miles and then returns to its starting point. The total time of the trip is 8 hours. And the question is to find the speed of the current. All right, we can let x equal the speed of the current in miles per hour. And like with the other distance problems that we've worked out, the best way to handle something like this is to make a small chart which indicates the upstream and downstream information. Keeping in mind that distance is equal to rate times time, we will have columns for D, R, and T, distance, rate, and time. Remember, when you're going downstream, you're going with the current. And when you're going upstream, you're going against the current. All right, we're traveling 30 miles upstream and then returning to the starting point, which means 30 miles downstream as well. When you are traveling upstream, you are traveling against the current. So you'll be going at 8 minus x miles per hour. In other words, the boat travels 8 miles per hour in still water, and from that you must subtract the speed of the current. On the other hand, when you're traveling downstream with the current, you add to the speed of the boat in still water the speed of the current. Now, if distance is equal to rate times time, then time is equal to distance divided by rate. Okay, so over here, in the time column, we can put distance divided by rate, 30 over 8 minus x, and here, 30 over 8 plus x. And the key to working out the problem is that the total time of the trip is 8 hours. That is, the time upstream plus the time downstream must be equal to 8 hours. The time upstream plus the time downstream must be equal to the total time of the trip. Well, the time upstream, that's 30 over 8 minus x. Time downstream, that's 30 over 8 plus x, equals the total time of the trip, which is 8 hours. Okay, eventually this is going to result in a quadratic equation, but what we have right now is an equation involving fractions. And the best thing to do in such a case is to get rid of the fractions. That is, multiply both sides of the equation by the LCD, the lowest common denominator. In this case, it's simply the product of the denominators, 8 minus x times 8 plus x. And when we do that, 30 over 8 minus x times 8 minus x, 8 plus x, the 8 minus x's cancel, and we get 30 times 8 plus x. Here, in the second term, the 8 plus x's cancel, and we're left with 30 times 8 minus x. And the 8, of course, has to be multiplied by both the 8 minus x and the 8 plus x. Okay, let's perform the indicated multiplications. Distributing the 30, we get 240 plus 30x. Here, 240 minus 30x equals 8 times, multiplying this out, we have 64. The outer and the inner terms cancel out. We have plus 8x and minus 8x. The last gives us minus x squared. All right, on the left side, the 30x and the minus 30x cancel each other out. 240 plus 240 gives us 480. 8 times 64, that gives us 512 minus 8x squared. All right, add 8x squared to both sides of the equation. We get 8x squared plus 480 equals 512. Subtract 480 from both sides of the equation. 8x squared equals 32. Subtracting. If 8x squared equals 32, x squared equals 4. X is plus or minus 2, but of course, we would only accept x equals 2, since it's a speed and we're not going to have a negative speed. So, the speed of the current, we believe the answer is the speed of the current is 2 miles per hour. The answer here, 2 miles per hour. Now we must check this out. Well, we can check it right here in the chart. If the current is 2 miles per hour, then upstream you're going at 8 minus 2, or 6 miles per hour. 30 over 6, the time upstream would be 5 hours. Downstream you'd be going at 8 plus 2, or 10 miles per hour. 30 over 10, the time downstream would be 3 miles per hour. The time upstream, 5 miles per hour. The time downstream, 3 miles per hour, giving us a total time for the trip of 8 hours, and that does check out. And that brings us to the end of this tape.